This notion of coherently moving objects actually comes from some very early work in vision that was done by the Gestalt psychologist. Gestalt psychology, which is really sort of the turn of, I was about to say turn of the century, turn of the previous century, really around 1900 or so, is when they first started thinking about the types of processes that the brain does in terms of what actually has to be constructed, if you will. That is, what sort of processing does the brain have to do? Now, they didn't really have computational models yet, so it was very descriptive, but it really was the precursor to a lot of the computational stuff that we all do now. So one of the founders pictured here is Max Wertheimer, and if you read, it says that one of the things that really interested him was at a train station you could see a set of moving lights going, you know, one, then another, then another, then another. And of course these lights would just come on, but he and everybody else saw it as moving, right? Saw these sequence of lights as motion. And this question was, how does that happen? What is the brain using? And he took a bunch of assistants who later went on to become also famous Gestalt psychologists. And they started looking at the way the human system groups things together. And they came up with a bunch of rules. So up here we have the not grouped, right? We just have a bunch of black dots. Well, it turns out that if you just move them a little bit, right, proximity will cause you to say, oh, I have 3 sets of 2 there. Likewise, appearance. So you see that there's black, white, black. All right. Similarity also in shape. So we've got horizontal ellipses and vertical ellipses. But one of the ones that they did that was kind of cool was called common fate. And you can see what common fate here means is that they're moving the same way. And then this got studied tremendously by all sorts of people doing work in psychophysics in trying to understand how far could a point move between 2 frames for you to see it moving. And then it turned out that there were actually different things. If you do it a very small amount, you actually see the point moving, right? You actually think that it went through all those little stages. And then if I put the point further away, it would be off and then on, you would get a sense of motion, but you didn't think you actually saw the point move. You would think it disappeared here and reappeared there. So you had this idea that something moved, but you didn't actually see the things moving. That was called a long-range process. I think these were done by Oliver Broddick, who was a famous psychophysicist. And so anyway, so this is this idea of how does the brain process such motion. Sometimes common fate is the only cue you have. So for example, I'm showing you a random dot image. You probably don't see very much there. What do you see? You see random dots. Good. All right, take it away. Yawn. Well, don't yawn, you'll go to sleep. All right, put up another one. There it is. Is that the same random dot image? You have no idea. Okay? But let me go to the next one. This is a GIF I made myself. I'm very happy. Now you're seeing 2 random dot images sequenced one right after the other. So what you're probably seeing is a square moving back and forth, right and left. All right? You probably see a pretty sharp boundary of that square. You actually think there's like an edge there. Well, let me stop it. No edge. Okay? That edge was manufactured in your head based upon the motion field. Okay? And our goal is to understand this computation of motion that would allow a system to say there's a boundary here based upon different motion.